all the sessions here. Yeah.
Sambhu sir, Nanda sir, Nanda sir, are you able to hear my voice? Sambhudutta Nanda sir.
Yes, sir. Yes, sir. Continue, sir.
Okay, so I'm going for the intro. So
Yes, sir.
the participant the session is on hands-on session for IM tools using HFSS by Dr. Sambhudutta Nanda, Assistant Professor at VIT University. Currently working as a assistant professor in VIT in the School of Electronics. He has obtained his doctorate degree from NIT Rourkela in 2020 and a master's from Parampur University, Odisha in 2014. Further, he has completed postgraduate program in artificial intelligence and machine learning from Purdue University. His research interests includes microengineering, 5G communications, soft computing techniques, metamaterials, and Internet of Things. He has published his research in reputed journals and presented papers in various international journals. Sir, Dr. Sambhudutta, sir, thank you for your time, and your session is open to you. You can proceed, sir.
Thank you very much, sir, for the introduction, and thank you all the participants that you are still here after a day long session. I was going to give a hands-on session using HFSS, but later on I decided that I'll be using some other tool from Matlab to show you some things so that you can use that in your antenna and preliminary research part. And further that also, we have a dedicated session from Keysight Technology. They will be talking about HFSS and the measurement part. So it will be a repeating thing for you. So I thought that it is better if I use some other tool and show you some other tool rather than some repeating tools like HFSS. Uh, in that regard, just let me share my screen and then I'll be starting. So here in I am in Matlab screen. So I hope it's visible to you all.
Yes, sir.
Yeah, okay. So actually, first my plan was that I will continue with going with HFSS, but right now we have very less amount of time as well, and also HFSS is going to be covered by some other experts. So I thought that I will be covering MATLAB. How is MATLAB related to our microwave antenna, and what you can do with that? So probably all the persons joined here, if you are associated with any of the institute or college, and most of the institute and colleges, they have the MATLAB full license. You may or may not have the CST or HFSS license, but MATLAB license will always be there. Means 90% colleges might have, and so many people don't know that MATLAB also has a dedicated platform or dedicated tool for microwave antenna design. So let me just start what we can do, what we can explore in the MATLAB. So what I'm going to tell you is just the thing that you explore in the MATLAB. So many things are there. I'll tell you the way to explore it. Fine. So in this MATLAB, the latest version I am using to 2021 version. The latest 22 to 22 version is there with some advanced features as well. So just open the MATLAB and go to the apps. So in the apps, you'll find that so many things are there. And here you can see the 5G antenna array design, antenna design. So these three are specifically for RF and microwave design things. You can design anything here. So let me start with this antenna designer. So I'll tell what we can do here and what is the limitation there. So if I click on an antenna design, then it will be opening an antenna toolbox for me. It will be not very similar to CST or HFSS, but it's the basic one. If you are a teacher, then you can use this feature to explain how the antenna work and basic simulation things rather than using CST and HFSS to teach so many things. And those who are researchers, for a preliminary research work or preliminary work of your main research, you can get into this. So here what we can do here, in this screen, just go to new. So once you click on the new, this will open one window where you can design your antenna and you can give your all the requirements to this instead of just trying it on your own and doing trial and error in your HFSS or CST. This is very time taking. So we can give all the requirements here. And how to do, what are the requirements. So first you can see here it is written radiation. So radiation, what kind of radiation I need? If it is a antenna that has to radiate in all the direction and the center point is there, then obviously I will be needing an omnidirectional antenna. Or if I need high gain, then obviously I need a directive antenna. So we can choose which one I can select. So both the things I'll choose and I'll select what happens after that. So one is I can take the directional antenna. So what happens if you select the directional antenna? So here it will filter out all the type of antennas are already predefined here, and it will filter out which particular antenna can be used if you want a directive directional antenna. So see here it starts from a waveguide. You can design a waveguide here, and you can analyze all the port parameters also. Then horn antenna, circular horn antenna, conical horn antenna. So all the types are there. Then folded dipole, V shape, meander. So all these antennas are there. It is also called as something called as carpet antenna. So if you click on that any antenna, then what will happen? This will be displayed. So this is called as a carpet antenna. Here you can have a 3D view also. You can see this is a 3D view of the antenna, and this is not exactly to CST, but you can have a very good experience in this to understand what antenna is. So all the basic structures are here. So further, if I go here, you can find that inverted flutter antenna is there, helix antenna is there, circular or rectangular patch we can use. So that is also there. So this all comes under the directional antenna. Okay, and the most famous we can see here it is a microstrip antenna, and this is a PIFA antenna. You can see this PIFA antenna is generally used inside the mobiles earlier. Now the technology has changed. So this PIFA antenna was previously used in mobile to miniaturize antennas. And then also you can see triangular shape antenna, E patch antenna, H patch antenna. So all these types of antennas are there. So let me just select the microstrip patch antenna that is very famous and everyone is aware of this. So we'll be selecting microstrip patch antenna. Now the point here is if a microstrip patch antenna is there, then where the feed is given. So that is the main question in microstrip patch antenna. So you can see this red point. So this red dot is connected to the top. So what is this one? The smaller rectangular you see, this is the rectangular, simple rectangular patch. The bigger rectangle you see, this is the ground patch. Now the question here is which one is the substrate here, because obviously we need a substrate. So by default, the MATLAB will take the substrate as a air. So that air means what? There is a ground plane and there is just a patch, and in between them nothing is there. So it considers that the substrate is a air. And you can see the feed is coaxial feed is connected, and the feed is given at this point. So what we can do with this particular antenna, let us see. Here again you can change the circular polarization or linear polarization, whatever you need. Based on that, again it will filter out the antennas, so you don't have to worry about that. And bandwidth, how much bandwidth is required. So if you need proper means a particular frequency, then leave it, it will, you can design at a particular frequency. If you need 10% bandwidth, then the center frequency it will take 10% lower side and 10% higher side, and it will give you the frequency band of that. So let us take it all means we'll be taking whatever possible bandwidth we can give. All means what? It considers all these conditions and filter out, give a filter out, filter of antennas. It applies a filter which has the antennas that can be directional. Okay. So next is this backing. So backing structure means what? It is generally used to avoid the reflections or increase the directivity. So there are different types of backings are there. So Devatos sir was talking about the loading effect on the ground surface. So it is actually placed below the ground surface so that the radiation or the minor lobes can be avoided here. So without no backing, let us go because we don't want to increase the complexity of the antenna. Fine. So after that, it is asking me the frequency. What frequency I can use here? So generally, let me take a 2.4 gigahertz frequency, which is generally used for WLAN applications or wireless Wi-Fi applications. After you have selected all these terms, what you can go for a just accept it. So what it will do, it will simulate your antenna and it will give you the result. So what we can do with the result? So let us see here. Fine. Now you can see here it shows me the antenna here, and here all the in the left side you can see it is showing all the parameters. And in CST you need a frequency sweep, or HFSS or CST you need a frequency band within which we are going to show the result of the antennas. Means if 2.4 giga, and then I need to see the result from 2 to 3 giga. So that also you can state here. You can see the range starts from 2160 megahertz with a step of 24 megahertz and goes to 2640 megahertz. So it will generate some number of steps. And if I need to decrease the number of steps, so that also I can do with reducing this step size. So if you make it 10, then it will be more number of steps will be there. But what it will do, it will increase the simulation time. So that's why let's make it just 24, which is by default thing. And then here you can see length. So these all the lengths are given in meter. So if you go to means calculate the microstrip antenna length in microstrip calculators are there in the so many online calculators are there you can use, or standard formula is there also. It's not very complex thing, you can use that. So the length, width and height, all these things are given of the patch. So that is very important. And then ground plane, ground in width, patch center offset. Patch center offset means where you are giving the patch and where is the we are giving the feed position. So if I change this feed position, then the wherever the feed is given in this, you can see this red dot, so it will change. Okay. Next is microstrip patch substrate dielectric. So you can see here by default it is taking the air. So what I can do, whatever material you want to test it, so you can choose that. You can take FR4, you can take Teflon as well, or you can take foam. So there are so many research papers I have seen they use foam as a substrate so that it will be like lightweight antenna they can design. So we'll choose FR4. Why? Because FR4 is generally used and the PCB fabrication it is easily available as well. And here you can see the epsilon 4.8 and the loss tangent is already given here. All these things are available in CST, but here it is very simple. You don't have to go to the complex designing the patch antenna. That is the advantage here. Fine. So next, if you see this FR4 set, so this is a FR4 set, but if you need something else, so what you can do, you can change this value as well. If you have a specific like whatever you want to give the epsilon r, you can select that as well. Okay. So that's all possibilities here. After that, microstrip patch and a conductor material. So this PEC means perfect electrical conductors. So this you will find in HFSS also, in CST also, PEC. So whenever HFSS hands-on session will be there, so you will be seeing that. Even in CST also, this term will come across PEC, perfect electrical conductor. Means we are considering that the copper that is used here or the metal that is used for conducting parts of the antenna is very means it is less. That's what we are considering. And thickness considering 0 means this is just a switch. No thickness is there, but practically there will be a thickness of 0.01 mm or 0.05 mm like this. Very small amount of thickness will be there. So these all are the things that you can play around and you can design your basic antenna. After that, you can directly go to S parameter, and if you click the S parameter, it will calculate the S parameter. So it is calculating for 21 frequency point. Why this 21 frequency point is written here? That is because the frequency range we have given here is for 21 frequency points. Okay, so that's why it is it is connected. Okay, now connected. So it takes some time to do the calculations. Actually, my laptop is on from the morning and it is very hot now, so that's why it is taking bit of time. But generally, it takes maximum 1 to 2 minutes to solve this. So what I can do, I'll go for a simpler one, so it will take less. Let me just check that. Okay, so I'll just directly go here. So the steps I followed, I'm just my voice is not clear. So actually, there is some internet issue here, I guess, that I can't help this day. So let's just take a simple dipole antenna and let's try to do it. Okay, so this dipole antenna we have just taken. You just see the S parameter here. So it will take less time because the antenna uh, structure is very less complex, and it is you see it is designed in the frequency of 68, 66 to 84 megahertz. So by default frequency it has taken. So the center frequency is 75 megahertz, and you see here it is resonating at around 75 megahertz. So here 75 megahertz, it is just near to your minus 10 dB. But this is properly not coming. Now the reason is why it is coming, because we have not given any kind of proper design to this. No frequency we have given. So randomly we have designed. So if you go like this, then you will not get any answer. So if I make the frequency change to 2.4 gigahertz, and then if I apply, 2.4 gigahertz, I want to design in this. So you can see at 2.4 gigahertz, we see a very good S parameter here. It's almost below minus 14 dB. Another point is why it is not very smooth. That is because from 2.1 to 2.6 gigahertz, only 21 points are there. So if I just increase the step size, then I can get some better visualization or very smooth curve I can get. So now you see here the curve is now little bit smooth here. Why? Because I did increasing the step size. So the same thing you do with the CST also. So that's what if you understand this particular application or in Matlab, then it is one easy to design in the CST and HFSS as well. So next is impedance. So generally these are used for 50 ohm impedances. By default 50 ohm impedance is taken. So if I draw the impedance graph, you can see here at 2.4, the resistance is near about means the combination of this impedance is you will be getting at your 50 ohms. So reactance and resistance is there. So total you will get 50 ohm of resistance here. So reactance value, you can see the reactive part is almost zero, and here you can see at 2.4 gigahertz the value of the resistance, that is the blue color line here, that is almost near to 50 ohms. So you can see 60 is here, and then it is near to 65 or 70 ohm it is coming. Okay, so that is the thing you can get here. And next is 3D pattern. So here also you can get the 3D pattern of this antenna. And in this 3D pattern, you can see this dipole antenna is omnidirectional antenna, obviously. So it is radiating in all the direction. You can see the 3D pattern like this here. Okay. So this is a dipole antenna, and the below you can see the antenna is there. So there are options also. If I select overlay, and then it will the antenna will show inside the structure itself and inside the radiation pattern, and you can better visualize that how the antenna is actually radiating here. So this is about the 3D radiation pattern. We can go for the current distribution as well. So in the current distribution, we can see that how the current is distributed in the dipole antenna. It is not in the current distribution. Okay, so we can see the azimuth angle and elevation angle radiation pattern as well. I'll check on why the current is not showing. So the azimuth pattern you can see here. This is how it will look like, the azimuth plane, and you'll get the elevation angle as well. So basically, this dipole antenna will give very good radiation pattern in elevation angle, but it will not give very good uh, uh, radi- radiation in azimuth angle. So that's the thing here. So you can see the same thing is happening here also. Elevation angle, the antenna parameter is very good, but azimuth angle, it is not that much of radiating. So how we can conclude that? If you see the radiation pattern here, so this radiation pattern says it all. So if I take it like this, so the elevation angle means what? You see the red and green line, these are the elevation angles. So in this direction it is properly radiating, but if you see the azimuth plane, so that means the plane of the antenna, so it's not radiating in that direction properly. Okay, so that's the thing here. So next, what is there? Optimize. There is an option of optimize here. So what you can optimize here? So in optimize, you can give that at which frequency you want to use it, then what kind of optimizer you want to use, then it's a trial and again. Okay, optimize means you give a center frequency, and then you give the length, that lower bound and higher bound. You give some length here, so you can optimize the antenna, because this formula that gave you the value, it might not be exactly same. So if you go to internet calculator, means some antenna parameter calculator in internet, and if you find the antenna for a 2.4 gigahertz, then this value will give you some different value, 58.70, here 58.7 millimeters. Okay, but if I want to optimize that my S parameter should be more good, not like whatever I'm getting, then we can optimize this antenna as well. So antenna length, then antenna width, then the feed offset. By default for the dipole antenna is at 0 position. You can change the feed position and you can test it as well. So all these values you can create, and you can optimize this, and you can take 100 iterations here. So these are two internal optimizers used for this. Means these optimizers are basically inbuilt functions of MATLAB. We cannot do any more control over that, but I will tell you that how it can be controlled. Okay. So now let us do one thing: how to write the code for this. So we'll be seeing that thing. Once the antenna is there, after you get that, okay, the S parameter is coming good, then you are getting the good the 3D radiation pattern. Then if I go to export and export as a script, so here if you go, now you can see one code is generated here. Okay, so this code actually you can play along with the code, and you can design your antenna. So you see the frequency range that we have given is written here. We can change this frequency range here. Next is the dipole antenna. We are going to design at 2.4 gigahertz. So 2400 into 1 e power 6, so that will be 2.4 gigahertz. Now you can change this frequency also, right? So then what you can do, plot frequency. At what frequency we are plotting our 3D radiation pattern. So whatever frequency we designed here, we can do the plot here. Okay, and this figure, this will show the antenna design to you. And this plot frequency, as I said, it's a frequency at which we need to plot the antenna. Next is frequency range. In which range we want to, means we want to analyze the antenna, in which range we want the impedance value, in which range we need the S parameter value. So everything is there. Next is we can plot the figure, just write the impedance. So these are all inbuilt function you can use. So antenna object and frequency range are the parameters. So if I give that, it will plot the impedance, will plot the S parameter for me. Okay, so you don't have to do anything. So what is the best part of this is, it is very useful when you start your research area, that at this particular frequency or this particular application, what type of antenna can be used. So as I saw there, if I go to new, and let's say I need a directional antenna specifically, and I need that it will be circular polarized here, and I need that the bandwidth will be, let's say, less than 20%. Then you can see these two are the only two antennas. They can give you this kind of operation. Okay, it should be directional, circular polarized, and bandwidth is greater than 20%. So this is only two antennas that can give you this kind of property. Now if I change the circular to linear, so what are the antennas that can give you linear uh, polarization with bandwidth of this much and directional radiation also. So see, these are the antennas. The Aguda antenna, you might have seen this Aguda antenna is used in television communication earlier. Nowadays dish TV is used, but this was earlier used in every rooftop. There will be this Aguda antenna will be there. So this is one of the application of Aguda antenna. So the thing is that in this filter you can use anything you want to design at the path of the research, so you can get some basic understanding here, and from there go on. So right now, if you want to do continue the research with the Matlab itself, now the code is here. If you have developed your own algorithm, so you can write your own algorithm here and do the optimization here, that you need to explore again what can be done. So let's say you want to particle some optimization to optimize the antenna. So then you can use the basic design antenna. Then you can use your code here, and then you can optimize the antenna. Every time what it will do, so it will give you a final result. So if I run this code, so what is going to happen? So I have to save it. If I run this code, then it will give me all the figures you see. Okay. So it is going to give me all the figures. Now, what's the advantage is here is, in this case, what we'll get here, all the figures are generated here. Okay. So the advantage is that if you are doing optimization with your own algorithm, you can write that code in CST. Now CST HFSS also accept MATLAB script. But in this case, it is very convenient because we are very familiar with writing MATLAB codes, or else you write in Python also, that code can be converted to MATLAB. There are online tools for that. So just convert that, write your code. Your antenna design code is already there. So if after integrating, every time you successfully run your code, you will get an antenna design, right? The point here is, it is not going to simulate your antenna for all the multiple time that the CST and HFSS does. So the result of the preliminary research or preliminary work will be very fast, so that you can have a conclusion. Then you go to the CST and HFSS for your final and the complex design. So like this, you can use this antenna toolbox of MATLAB, and also you can do one more thing. If I copy this code, and if you don't have, let's say you don't have MATLAB, so what I can do here, I can go to online MATLAB also. So I can just go to online MATLAB, and I can use this code in the online MATLAB. If you don't want to download, okay, if you don't want to download MATLAB, your system is very slow, then what you can do, go to online MATLAB, open online MATLAB here. Let it just open. I just opened earlier. So the online will open. Now we'll go to a new script. So this online editor does not need your system requirement, what speed you have, what processor you have. Nothing is required for that. So what you can do here, just go to a online MATLAB editor. If you have the license, then you can use the same license here, like use your college email ID. It will open here. Then I have copied the code from there and I just pasted it here. Okay. So after pasting it here, I can run this. So this code will be running online itself. It will store the code in your cloud, in the cloud account, and then it will run the code. So once it will run the code, then it will give you the output. Your system resources are not going to be used here. So here it has generated these figures here. This is the current distribution that is not shown in the offline MATLAB. Now this one is the S parameter. You can see here the same one. You can see this radiation pattern as well, and you can change the radiation pattern also. Means you can change the variables here, and you can use the radiation pattern. This is the impedance plot also, and this is the antenna that is designed. The simple antenna it will give you. Fine. So all these things you can do with online. If you want, I'll just paste this code in our WhatsApp group, so you can go to MATLAB online editor and you can try it. Uh, Also, I wanted to show some filter design and waveguide design also using this, but as time is very less, I had to go very fast and I think this at least one toolbox you have understood how you can use MATLAB for your preliminary antenna research, and it will be very helpful as I know and I have used it also. So with this, I want to conclude this session here. And if you have any questions, please put on the WhatsApp, and I'll try to answer each and every question that is possible. And one more thing before ending, I'll show you. So if you go to the apps again, here antenna array design. So I have seen so many questions that are being asked from antenna array. So here array designer is also there. If I go to click new, then here you can also design the antenna array for your preliminary research area. So array of which antennas? Array of the basic antennas you can design, and you can see these are the basic structure of array, how you want to place it. So see a linear array is there. Okay, so linear array means it will place the arrays like this. You can include how much number of array elements you want. So if I make it 5 here, down it is there, then it will create a 5 element array for you. Then you can play around that what amount of array is required for you. You need 3 elements, 4 elements, 5 elements, or whatever is required. And you can make array of any of these antennas. Okay, so basically famous, if I go to the microstrip antenna, then how the array is going to be designed. So you can see here, this is one microstrip antenna and it is going to place the array in a one line. But if I see a rectangular array, if I want to design, then this is how it will design it. Okay, so rectangular array will four sides, you can see it will design those arrays. And circular array is also there. Then conformal array is there, right? So conformal array, it can only take this particular antenna, it cannot take all other antennas. So like this you can play around with this software. And with this I'll try to I want to end the session here because I am running out of time as well. I am open to questions, but WhatsApp only. I will try to answer each and every question you ask there. Thank you, sir. Thank you, Rajsekhar sir, for this session.
Thank you, sir, Dr. Nanda, sir. Thank you for your valuable inputs, the design of antennas in by using MATLAB. So, dear participants, if you have any queries, quickly you can ask. We can wind up the today's session. If you have any questions, you can ask now.
Yes, sir. If any questions you can ask now, or else you put in the WhatsApp
Yeah,
while we
I can put also.
call.
Yeah, can,
Because we have already passed the time. So many people might have to leave college, and also that will be good.
yeah, yeah.
Can I ask one
Uh,
question?
okay, sir.
Yes, sir. I can take one question.
Of course, sir, you explained the details of the MATLAB, but when the EM solution softwares are available, why should we go to the MATLAB? If you don't have, then it's okay. Otherwise, the features which we have in the EM simulation software like HFSS, EFT Studio, ICD, so all these features can we get in MATLAB also? I have a doubt.
Yes, sir. As I have said, is if you are starting your research, or else if you are a teacher and you want to make the student understand about antenna, then this is one is a very basic for a preliminary things, and so many things can easily be done here. You don't have to think about that, like the array structure, like directional antenna. If you have to design, what are your options? So if you just want a preliminary research, it's okay, but it's not for the final research like CST and HBCs. The intensive things cannot be done here. So that I have told.
Next, one thing, for example, to find out the radiation pattern in EM simulation software, it is very easy. But same thing if you want, can we implement it in MATLAB or we have to write the MATLAB programming for the same?
No, no, you don't have to write a MATLAB programming. That can be done with that app as well. But if you go to the MATLAB programming, that's what I said. Because if your system is very slow or resource is not there, then you can use the online MATLAB. Use that code there. Do your changes in the code. Then you can get the result there. It doesn't depend on your system requirement. So that's why the code will be important there.
Yes, I have one more thing. That is, if you want to plot the 2D radiation pattern, okay, in spectrum data, it is difficult. Whereas in MATLAB, is it possible to take the same data readings from the uh, DNA and put it in the MATLAB? Can we use the result? Because we are facing
Yes, yes, yes,
problems.
yes.
We are
Yes,
facing
it
problems
is possible.
in the radiation pattern.
Yes, sir, it's possible. It can be done.
Okay, what should be the procedure in that situation? Hello. What should be the
Sir,
procedure?
can you please ask again?
What should be the procedure to get the 2D radiation pattern?
For getting a 3D radiation pattern.
2D, 2D. 3D is very
Two,
easy.
2D radiation pattern, sir, it is there already. Azimuthal plane or your elevation plane you have to select. It will give you the E plane. E plane, only E plane for that, not H plane.
Okay, only E in MATLAB.
Yes.
Okay,
Yes, sir. Yes, sir.
thank you.
But for if you need H plane, then there is documentation is there, and we can search for that which command is used for H plane. By default, if you only write pattern, it will give you the E plane. For
Okay,
H plane, you have to write specific command which is not available in the app, but by coding you can do that.
okay, okay. Thank you.
Okay, thank you, sir.
Okay, sir. Thank you, Dr. Nanda, sir. Okay, dear participant, that's the end of today's session. Day 2 is over. And tomorrow, day 3, session 7 is going to start. Session is going to start from 10 a.m. Its topic is RF measurement from the industry person key site solution. So meet you tomorrow at 10 a.m. Thank you. Thank
So
you.
which lowest version of MATLAB has got these facilities?
You can get it from 2020 onwards.
Sorry, I could not get you.
You are asking which version of MATLAB has this option?
Yes, sir.
2020 onwards, it is there.
Okay.
2020. Yeah.
Okay.
So if your college has license, then obviously all the license include all the toolbox. So it should be there. You can use.
Or we can just upgrade it.
Upgraded means you can use. There won't be a problem. They include all the toolbox generally.
Okay. So we have some licensed version here, so we'll just see it.
Yeah. Okay. If it is not there, then you can manually install the license. I mean, not the license, the toolbox separately. In your system, it might not be installed. You can install separately. The toolbox only.
Okay, sir.
If nobody is using, then probably it might not be there. So the license will be there, but nobody might be using. So you can just install it and use for your own purpose.
Okay, sir. Okay, sir. We'll do that.
Okay, thank you very much.
Okay, sir. Thank you, Dr. Nanda, sir. So dear participants, can leave today.
Thank you, sir.
So see you tomorrow at 10 a.m. Sure.